go from there. All yours.
You're good. Okay, excellent. All right, well, welcome everybody. I see a bunch of people have joined in. So this meeting is being presented by Andrea Ray, Getting to Best Available Climate Science Case Studies Connecting Climate Science and Ecological Modeling for Land Management Decisions. And I'm Stacey Lynn from the North Central Climate Science Center, and we have others from the North Central Climate Science Center on the call. But to start off this WebEx, we'll first have Andrea present her presentation, and then that will be followed by 2 to 3 minute project updates from our various projects and letting us know about their recent activities and achievements and such. And that will go through our foundational science areas, management-focused projects, and capacity-building projects. So why don't I just turn this over to Andrea, and if I can figure out how to do that.
Stacey, this is Shannon.
Hi, Shannon. Yes.
Hi. Hey, I just wanted to remind you guys that we have this other webinar that follows on right at the noon hour after this one. So
okay.
I at least am going to need to jump right at noon to go, and I saw you had me on the agenda to give a little adaptation overview. So I just wanted you to be mindful of that that other webinar that's right on the heels of this one. Thanks.
Right. Well, you're right at the front of the presentation, so that should be well before the end of the meeting. So since you're the first one on the agenda here, so hopefully we'll be good. But yes, there's a bunch of people who will be leading for that, and I understand that. So okay, so let me turn this over to Andrea. And just to let everybody know, while we're setting up Andrea's desktop share, that we are recording this session, and we will be posting that on our revamped website. We'll be posting a link. And I'll start sending out notices as soon as we have those posted, so that people on the list who have not been able to join the meeting will be able to join, or at least to watch after the fact. Okay, Andrea, I think you have the controls at this point, so I'm not seeing your desktop.
Okay. Are you seeing it now?
I'm not. Is anybody else?
Nope.
Interesting.
You have a share your desktop or application should be popping up.
Well, there was something that popped up and said, oh, maybe I need to do share desktop.
There you go. You have to click share your desktop. There you go.
Yeah, it wasn't giving me that until I went to a different. It wasn't. It originally just said you are now sharing your desktop. So. Anyway.
Oh, interesting.
And I was expecting to have to click on something, but it gave it on a different.
There we go.
Anyway, okay, so I'm going to talk about this pilot project that North Central funded. Funded USGS ecologists in that first year of funding to work with this National Climate Predictions and Projections platform, which is a primarily NOAA-funded effort to make climate predictions and projections more accessible and usable by a wide range of users. So I want to just briefly thank a number of the people who were involved in the project: Amy Simstad and Dominique Bachelet, Laura Perry, Pat Shafroth was actually the lead on that project, Max Post-Vanderberg, Rick Soja, Joe Barsigli also worked a lot on this, and of course Jeff and Dennis. And really the motivation for this is that better climate information is really rarely sufficient. So just getting more data, more pixels is not usually enough to actually be able to use the information in some sort of impact analysis. And it's usually not just a problem of handing off data and information. In fact, there's been a proliferation of data portals that do try to make the kind of technical handoff work better. But for the most part, those haven't solved the problems of understanding what's in those climate projections and which set you might use or not use. So there's little guidance or translational information available at most of these sites. And another big issue is evaluation. Most of the evaluation of different climate models and how well they might either represent the past, so when they're run in simulation mode to see how well do they capture the climate of the recent past. Most of that is buried, I'll say, in climate journal articles. So if you don't have access to those, or you're perhaps not a PhD in climate science, they might not be very easy to use. So this project was a collaboration with the North Central to try to get at some of those. And one of the things that we thought going into this project was that to solve this problem, you'd need a suite of information to aid in translation of numerical climate projections into what we'll call usable knowledge for applications, and in this case, the ecological response models. And this would include the technical and scientific aspects, but also the results of objective quantitative evaluation, guidance on appropriate uses and interpretation, for example, understanding the advantages and limitations. And then a word that's come up a lot has been quantifying uncertainty, and we think it's really more of an issue of characterizing and interpreting uncertainty, and I'll talk a little bit more about that later. And then potentially information on historical and current climate and how it relates to the future climate. So, and then of course we think it's best developed with people who might actually use the applications. So the North Central ended up funding 4 proposals, and I'll tell you a little bit more about them, but I just wanted to say this slide is not where I expected it to be. Oh, okay, so I'm going to back up to this. So these are the 4 projects with the overarching goal to explore this idea of best available climate information to support key land management decisions and how to provide that information. And there were 4 of them: Riparian Corridors, which is Laura Perry and Pat Shafroth, and it's I'll talk a little bit more about that in a minute. Sage-grouse habitats up in northern Montana, and this is Rick Soja and a group out of the Northern Rockies Science Center. Grasslands and Forests, this is Simstad and Bachelet and their group, and really thinking about whether there's woody encroachment going on in the region of Wind Cave National Monument and surrounding areas, and how fire management and potential fire prescription might alleviate what they're seeing as a lot of woody encroachment of shrubs and trees onto grasslands. And then one that was really carried on more from the standpoint of climate information. I'm actually going to skip to the next slide here. Down here in this identify management options of this overarching conservation goals graphic that you're all pretty familiar with. The work that Max Vanderpost, and I saw that he's on the phone, so hi Max, was doing was really to look from the management options section and see what information is needed and the value of climate information in those projects. The others are the sage-grouse project kind of overlapped this assess vulnerability and the management options quadrant, and then the other 2 were really in the assess vulnerability to climate change area of that conservation goal. This is kind of how we saw the parts of the projects coming. NCPP providing the climate data and documenting the challenges and decisions made while we were determining appropriate use, and then developing the translational information, with the Science Center being sort of this in-between between the climate information and the management objectives and goals. And so their scientists providing the ecological response models, and in that case, some of those that we were working with were PRMS, Uniforce, a phenology model, things about seed recruitment, landscape level model. MC1 was something that the Woody Encroachment Project was working on. So I'm going to talk through somewhat a manuscript that we're working on that's a preparation from the experiences with this. And so the approach in this has been to document how these ecologists are currently using climate projections and the kinds of choices they've made. Like, why did they decide to use one or another set of usually downscaling? What kinds of evaluation and comparisons are they interested in? And then a feature in here is going to be, what do we think they should be interested in? What as climate scientists do we want to suggest that would be the best choice or an appropriate choice? And then it's going to be organized around top 5 or so things that climate scientists want ecologists to know about the climate models and downscaling, and that we think generally aren't understood if you're not working side by side with a climate scientist. So, for example, one of these is that the ecological hypothesis testing could be biased by your choice of climate data. And if you don't understand or you don't recognize, I think people pretty quickly understand the implications of this, but if you don't recognize that the choice of climate data could bias your results, you could actually potentially have flawed results based on an inappropriate choice. And then from our observation, a number of things, top 5 or so things that ecologists need that aren't readily available. And these are intended to be kind of challenges to the scientific community, the climate science community, to make those more available. And in some cases, they are available, but they're buried in journal articles and in a way that you can't easily get the same kind of information on different global climate models, for example, or similar kinds of information on different downscaling products. So they're not readily available, even though climate scientists might say, oh, yeah, you can get that. Recommendations for climate services based on this, and then a bit on the outcomes of the project and the future work that's an outgrowth of this. So I'm going to talk just briefly about 2 of the projects, and I'll come back around to the other 2 at the very end, and the kinds of issues that they were interested in. And I think most of you, having been around North Central for quite a while, know something about these different projects, so I'm not going to spend a lot of time on it. But I just thought that the whole riparian corridors issue was really fascinating. The issue here is cottonwoods, especially, flower and set their seeds so that in a evolutionary or a Darwinian sense, they manage to have seeds survive enough times over a number of years to continue there being cottonwoods in riparian areas. And the concern is that as temperatures warm, cottonwoods may respond to a temperature signal and set their seeds either too early or too late for them to have the appropriate conditions on the edges of the river, which are very much dependent on when peak flow is. So the timing of peak flow could get disconnected from the timing of setting of seeds because of the 2 different things. And a couple of the issues that came up were just the different kinds of estimations of temperature coming from different gridded observational data sets, needing daily data for calculating these chilling and forcing units for bud bursts, and how the stream flow results calculated from PRISM, which compare to DayNet-derived technology. And these are not things that are impossible to figure out, but they're just things that we didn't necessarily think about at the beginning of the project. And this is just an example that you can have different observational data sets, PRISM, DayNet, WorldClim, and PRISM and DayNet. And if you do a difference map, and this is from a published paper, you can have, these are all different estimations of the temperatures. And I think climate scientists know that what these are intended to be is a way of gridding the data sets, gridding the observations so that you have an observation at every point. but it's not always understood, I think, that these are really an estimation of what's happening at that point. And so it shouldn't surprise us that there would be slightly different estimations at different points. But you can actually end up with a degree or two, I think this is a degree or two Fahrenheit, which is, can be one of these things that leads to a false sense of what the results might be. The Grasslands and Forests Project I talked a little bit about already. Some of their big issues are about CO2 fertilization and how that relates to temperature. And the climate projection issues are availability of full-time series. So the MC1 ecological model wants to have a number for every year. And it turns out that that's not really how the climate projections are intended to be used. And so we didn't solve this problem, but it was kind of an aha moment that the ecologists were using the climate data as an annual prediction for each year, like what's actually going to happen in 2021, 2022, 23, 25, and the sequencing of those years, whereas we would say that that's really just intended to be a statistical representation of a climatology. And we haven't really figured out how to solve this one, so this is one of the big ones that we would say that climate scientists should work on. And then there's another big topic that came up with this, although it's also of interest in some of the others, is calculation of ET variables, and that's actually spun off a whole new project that I'm not going to talk about, but I'll mention briefly later. I'm a little tired. I think, when did I start? About 5 after? 8 after? I'll try to speed up here. So this is just one of the issues that came up in the SimStat project, is this dynamical downscaling that's out of Steve Hostetler's group, funded by both USGS and BLM. Turns out to be kind of complicated to use, because if you're in a place that has multiple tiles, you can get more than one answer. And this kind of, this shows that the different tiles can have different answers compared to what's been the recent future. So just deciding how you're going to handle this was an issue that they came up against, and they actually ended up deciding that they weren't going to use this downscaling, but they were going to use a different set of downscaling because of some of the complexities of this. Another issue with the SimStat project, but with lots of different projects, is that there are about 22 global climate models. 16 of them are thought to be the better climate models. That's leaving out a few that have some really big problems, the models that were used in IPCC. And most downscaling, especially dynamical downscaling, only does a couple, maybe 2 or 3 of those. Hostetler downscaled only 2 of the IPCC GCMs, and another that was used by IPCC, but it was only used in the paleo part. So you could easily end up with a future, for example, if you didn't plot something like this, which is the change in precipitation compared to the change in temperature. You could end up picking a model that's, say, hot and dry, and not really realizing it. And it's easy to solve that. You can easily download data like this. This is statistically downscaled data, and you can easily download it and plot it something like this, and look at your data and see what kind of climate is represented in the downscaling that you've chosen to use. Or you could use it in another way and use a plot like this, and then decide, well, we'd like to have a wet, warm future. Perhaps pick one GCM from each of these quadrants, and maybe the ensemble mean, so that you had a different set of futures to consider, a small number of futures that are at least reasonably representative of the different possible futures. And this is another way of showing that, and we chose to plot, just to simplify the plot, 5 GCMs that are being fairly regularly used in downscaling. These were downscaled by either Hostetler or Ray Felt, who's a Forest Service researcher who's done a lot of vegetation modeling. And you can see that this is time here across the bottom and percent change from a 1950 to 1999 average. And you can see that some of them are very different than others. So the percent change is up to in the 20% by 2080 to 2090 for some of the models, but it's a much smaller change for some of the others. And this is partly because the different models are representing different decadal variations, but it's also because some of the models just tend to stay cool or wet or not. So you kind of have to look at these so that you have an understanding of what might be in the models that you've downscaled, the GCMs that you're going to use. So back to this issue about time series, which as I said, is of interest because the MC1 model, ecological model, wants time series. The different GCMs, and I'm showing the same ones that were that I showed in the last slides, have different histories. And some of them have warm periods, and this is exactly what we expect to happen. We just don't know which ones of these are right. But if you only used one of these and you assumed that that was a time series that was somehow truth for the future, the ecology that you will get out of that future is going to be very different than if you used a different time series. And so again, we don't have a good solution for this yet, except plot your data and understand what kind of time series you had. Consider whether you might want to pick a different model trace so that you got maybe a warm time series or a cool time series, or consider that different ones of these might give you different experiments, like what if you had a long cool period and then a longer warm period? What's the ecology that comes out of that? What's the vegetation distribution, for example? So know what your model is giving you, or know what the climate model is giving you. So here's these top 5 at the moment things that we think ecologists should know. And as I said several times, give them the same critical eye as the ecological data you use. I know that most ecologists end up plotting their data, looking at it in different ways. That helps inform the questions they're asking. And I would suggest doing the same thing with the climate data, getting a climate scientist to help you with, because in a lot of cases it's not that hard. And so, for example, the kinds of plots that I've just shown you and Perry's comparisons of Greta's data sets, which I didn't show. We'd like to urge caution about downscaling to a really fine resolution. It's tempting because a lot of ecological variation and observations are at this scale, but you need to understand that you're not really getting any added value about climate at that resolution, because what's going on is some sort of, at that point, statistical downscaling like PRISM, and it's basically doing one of these interpolations. One of the things that's changed for me in the course of this project is I now feel like I'm okay that the ecologist might do this because it makes the data be ingestible by their model. I just don't want people to think that they actually have much real information at 10 kilometers, and especially at 1 kilometer, except as comes from the interpolation of the data to account for elevation, slope, aspect being does it face north or south, and that sort of thing. So, and that's important information, but it's not actually telling you that you know more about what the climate future is in that area. That's coming from a much bigger and being set by a much bigger scale. A third one, potential pitfalls of comparing studies based on one set of GCMs to studies based on a different set. And we've encountered this several times in looking at different ecological studies or even looking at different climate impact studies. And since most projects only use a few GCMs because it just gets to be overwhelming, you could easily end up making a false conclusion or setting up a false set of hypotheses that are based on the GCMs providing a different climate, and not that something else is going on in the ecology. So our initial solution is to look at the output as we did in some of the figures that I've just shown, and have that inform your conclusions. Or know, for example, that you're intentionally choosing to compare a warm, wet climate with a cool, wet climate, or whatever set you might choose. And so we've been saying this, put the GCMs in context so you know what type of climate was downscaled. Bioclim indices, they're widely used, but also various other kinds of 30-year averages are used a lot. And my concern is that this may wash out the extremes and the variability that are actually the important features driving the ecology. I think if you have a hypothesis that's what's driving your ecology is runs of dry years or runs of wet years or cold winters, you're not going to get that out of these 30-year averages. And it's not very hard to do the statistics and the analysis to get those kinds of things out of the data versus just the 30-year average. In most cases, you could probably use it doing an Excel data set, an Excel spreadsheet. And so we think that there need to be better ways to compare climatology to ecological sequences or better indices. And then finally, I think it's worth thinking about in choosing the climate information, choosing the climate data, how are the important climate dynamics represented in the GCMU? So if you've got something that's really important, the monsoon's really important, or the storm track, then that's something to consider how well that's represented in the GCM. Okay, I've got maybe just 2 or 3 more slides. These are the kinds of things that aren't readily available. ET and TET and drought indicators. This is actually spun off a whole set of projects and a set of meetings between some climate scientists and people at North Central. Seasonal to interannual outlooks, although most of what we talked about was climate change, especially in talking to Max Post-Vanderberg and the project up there, these are something that are not being widely used in management, and I think this is something that climate scientists need to work on being more available. And in this case, this is climate scientists who are doing the projections of the next few months to a year or a couple of years. And we call those predictions or outlooks. And they're not the same as the GCM climate projections. Although in a few cases, not any of the people that we worked with here, I've seen people try to use the next several years of climate projections as a seasonal outlook. So it's a longer story. I can answer a question later why, but that's not the way that's not the way the GCM projections are intended to be used. Downscaling I already talked about, but climate scientists need to make it more clear what you get meaningfully at a smaller resolution and what an appropriate resolution is that we might actually understand something. Decadal outlook, we're hearing this from a lot of different people. Many management issues are at the 10, 20, 30-year time scale, and you can't really use the GCM output. It's not intended to be used as a 10, 20, 30-year prediction or projection. For IPCC 5, the one that just came out, there were some runs that were specifically intended to be used that way, but most climate scientists will tell you that those are still really researchy. We're probably at least a few years out from doing something well with that. It's an active topic of research. And yet there might be a few things that we could do to understand whether there's a likelihood, maybe there's a shift in the risk of the odds for one or another condition over the next 10, 20, 30 years. And the time sequencing of years I talked about. Many ecological questions are sensitive to sequence, and the climate data, the climate projections are not intended to be used that way, but because it's so important, I think it's worth us figuring out what an appropriate way would be to do that. A lot of these are the same kinds of things, the recommendations for climate services, because this is kind of a big issue for NOAA. Climate scientists need to do a better job of explaining and articulating what different products shouldn't be used for. This idea of more translational information is part of that guidance on appropriate use and interpretation. Most regional and downscaling projects often don't have sufficient funding and resources to support proper documentation and ongoing user support. Often they're done as research projects and people move on to the next thing. There's a few exceptions to this, but for the most part, this isn't happening. And then because these climate projections and gridded observational data set are widely available, they're easy to download, but there's just little overall guidance, which we've talked about. I've already talked about a bit. And these questions could be consistent information on evaluations and guidance on use. Intercomparing, we could do provide some intercomparisons, analysis of how different downscaling products compare. And this is all the kinds of things I would consider translational information, and those would also include things like summary narratives of how the climate has changed and how it might change, and issues about uncertainty. So, final slide, and I'm going to take a sip of water while I let you look at this for a second. I'm going to close that. So across the project, we think it's really been a successful pilot, and that it accomplished pathfinding on how to connect climate science to ecological models. Number two there is it really raised the level of conversation and collaboration between climate scientists and ecologists. And I would say that one evidence of this is the North Central, misspelled there, North Central Climate Science Center's ET project that's been ongoing. Some really interesting discussions and some funding, but I think it's also influencing already how ET is being used in some of the more newly funded projects, and what several climate scientists are doing with respect to their ET work. The first one there, I'd really say that it jump-started the experience with these projects, jump-started our analysis on projects funded for the next year, like the work with Susan Scoggin and her group. And it definitely, one of my other projects is this Wyoming Basin Rapid Eco-Regional Assessment. And because of these conversations, we started at a higher place in the conversations with Wyoming Basin. And I think I could probably say that's true of several other projects, but that was just the first one I thought of. I just wanted to talk a little bit about the other projects. Plains and Prairie Potholes was really about the value of information. And Max and I, several weeks ago, just had a really interesting conversation on this, because they ended up picking a management issue that is more sensitive to seasonal interannual information than to long-term climate information. So it ended up not being, well, he learned a lot and established a methodology for looking at the value of climate information. It didn't quite fit with the kinds of information we thought we were going to work on. So, but that project is one of the reasons for saying that I really think that there's more of a value for seasonal interannual information that's currently, I think, not getting as much attention, because there's just been this really big fascination with the climate change. But the seasonal interannual timescale and the predictions and outlooks there, I think, have a real potential for a lot of ecological questions, and especially for management questions over the course of a year or the next several years. Management interventions or that might be done every year, and you get to do something new every year. The Soja project, and I think I misspelled his name, I always forget which, whether it's DJ or JD, they weren't really ready to get to climate information. They hosted at least one, I think, really effective workshop that got people talking and thinking about questions, but they hadn't really nailed down what the ecological connection to climate was. So it wasn't really at a point of being ready to hand them and work on providing them climate information into an ecological model. So the the lesson is that neither of those were quite appropriate to what we ended up doing, but they had their own kind of benefits to North Central. Plains and prairie potholes, for example, that area and management in that area is a really big issue for that LCC, and the whole question of how climate might relate to sage-grouse is a really big issue for several LCCs, not just the Great Northern. So some of the other outcomes are several manuscripts and publications. I'd also say that the discussions from this contributed to other projects. So, for example, Amy Simstad, yay, Amy, that your report, I think Amy's on, the report on the wind cave scenarios project came out, and I think that the discussions we had really benefited the writing of that. Let's see, Viz Trails. Jeff can talk a bit more about this, but there's a follow-on to develop a Viz Trail system for the U.S. monthly water balance that came out of the Shafroth Perry project, and then this Badlands scenario planning project, and this is related to that wind cave scenarios report, is something that's ongoing and also seems as if it's going to benefit from this project. So that's all I have, I think, yes. And I'll be happy to answer any questions.
Well, thank you very much. And does anybody have any questions for Andrea?
I have a question. This is Shannon. So thanks, Andrea. That was great. It's always nice to hear you talk about this stuff. Really informative. The question I have is about the scale issue and communication with managers. So you talked about, you know, the issue of making the scale meaningful in terms of a scientific analysis. So, you know, the potential of fine resolution not really giving you meaningful results when you look at ecosystem modeling. And then you talked about, sort of on the other end of the spectrum, seasonal outlooks. But what about the issue of translating higher resolution climate analysis at a management scale? Because I think, like you said, you know, from a value of information perspective, perhaps the seasonal forecasts are more highly valued for day-to-day or, you know, interannual sort of management decisions. But there's also a lot of value, I think, in the ability to take those larger resolution climate projections, but be able to translate them for people in places at finer resolution scales. And what's your sort of thinking about that, and what might we do as a community to get better at that?
I'm not entirely, you talked about several different things in that question, so I'm not sure which one you're talking about. I want to make sure I say that it's not that there's no meaningful information at that small scale, but that you're not getting additional information except from the interpolation at a point. So, and so I don't want people to think that because it got down to 1 kilometer that you know something more about how climate change is going to affect that, because really the climate signal is coming from a much larger scale, and I don't think I'm articulating that quite right. And then you asked about the seasonal and annual forecasts?
Well, no, so I'll just stop you right there, because that's exactly the point I'm trying to dig into, which is, you know, if you are downscaling to, say, 10 kilometers or 1 kilometer, and you know, the notion that you might actually be sort of compounding uncertainties when you run that through an ecosystem model. So what about when larger resolution climate projections are presented that haven't been run through an ecosystems model, for example, but communicating what that might mean at a scale that's meaningful to managers in terms of the ecosystem management? Well,
the thing I'm thinking about there is, so larger resolution, there's the GCM scale, there's the downscaling scale, and there's several different downscaling scales, and then there's running that through the ecological model. I've actually been pushing the people who've been working on analysis of the GCM scale of results to begin talking about them in the context of the kinds of weather phenomena that we might be familiar with. So, for example, much of the northern north-central region is in an area where we think that the storm track is likely to be pushed northward, and therefore it's more likely to be wet. And you get that from multiple different, more of the GCMs show that than not. And when you start talking about that's because the storm track shifts, then I think that's something that the managers can understand. Or if you start talking about how in the GCMs, how the Great Plains low-level jet might be affected by climate change, and that then it's a major moisture source to the plains. What that means, those are the kinds of things that I think we need to be saying in terms of narration or words, and not just as pixels or on a map, or lots of times that information is presented as a map, but we don't talk about why. Same thing with the monsoon. If we think that there's certain kinds of, there's different analysis of the monsoon, but it often doesn't get described as here's the impact, the large-scale impact of climate change on the monsoon, in a way that I think people would be more accessible to a lot of people. And then you can say, oh, well, now I understand why the downscaling shows that this is a wetter area, or that spring is drier, or winter is wetter, or those kinds of things. Does that make sense?
Yeah, absolutely. Thanks. And that's exactly the kind of thing I'm trying to get at. And it's too bad Joe Barsuglia is unless he's just on the phone.
Joe and I have been talking about this, and I feel like I'm not articulating this very well because we're just sort of trying to figure out how to say this. And so.
Yeah, no, I think you're onto something there, and this is something that I think as we move forward with the foundational science areas, which is why I mentioned Joe Barsuglia, these are the kinds of things I would like us to look at as we're thinking about how you're doing these analyses at different scales and communicating that to managers. So,
so Laura Perry, is Laura on the call? Okay. So Laura is the lead author on a paper about riparian habitats that I've just been looking at, because a paper that I'm an nth author on with Richard Seeger, they are looking at the CMIP-5 models at the GCM scale to see what the different dynamics are. And I've suggested that we put in that paper either a table or a list of these are the kinds of things that we expect to happen. In Laura's paper, there's a table 2, there's a column of precipitation tends to get higher, tends to be less, or tends to be more, and that kind of thing. And it's all really general because that's probably all they really had access to. A paper that got published in 2012, so, was written a year or two before that. But can we improve on that, the kind of information in that table, so that we're giving ecologists a better sense of what the larger scale changes are, so that they can be, then you can understand what might be happening at a smaller scale. I saw Steve Torbett raise his hand.
Sorry, this is Jeff. Thanks a lot, Andrea. This has been good, but I do want to make sure we stick with at least a little.
Yeah, you're already past time. So, Steve, if you don't get to answer a question, just give me a call later.
Well, if I could it's not a question as much as a comment, and you and I have talked about this, Andrea, and just like put it out there on the table for Jeff and others that the service is at a point where we need to have a discussion about what kind of climate assessments we're going to need given some species we're concerned about, and have these discussions ahead of time so that the range of climate models, the range of analyses is done appropriately from the get-go instead of the back end. So I just want to provoke a further discussion about this in a few weeks.
Sounds good. And I took more time than I should, so I'll just finish up. And if anybody has a question, you're welcome to shoot me an email or give me a call.
And thanks again, Andrea. I'm looking forward to working with you and getting this paper kind of wrapped up so we can kind of get this out
really
there.
am, yes.
So, yeah, well, I too have to accept some responsibility in trying to push it along. But I think now we've got everything in place to write it up. So I would ask people to. The NCPP investigators will be on that paper, and the rest of folks can just watch for it to come out. I don't know, Stacy, if you can show the list of kind of who we were looking to hear from on the check-ins, and we've only got about 10 minutes. And in the interest of time, I think, Stacy,
we don't have everybody on the call anyway, so we can just run through that. Start with Shannon, since I know she's going to be leading the call.
Yeah, because I guess Joe somehow didn't know about the meeting, which is too bad.
Joe actually got called away to a different meeting. I don't remember what it was.
He indicated he didn't find out about this until Friday. So we need
yeah,
to make
it was
sure.
this meeting. Oh, okay.
At any rate, I can tell by looking at the list that we've got the foundational science areas. We got Dennis on the phone. We don't have Joe and we don't have Andy, and Andy was on travel, and so is Joe. We've got and Andy is one of the 3 management directed projects. We got Betsy and Bill on the Southwest Colorado, and we got Susan Scoggin with the surrogate species. Andy's white bark pine. Andy's not here. And then we've got kind of our capacity building. I don't see Geneva, but we got Brian Miller and me in the room with respect to the tribal phenology and then the training. In the interest of time, and this is the first, we've said that we want funded investigators on the call, and those 9 different projects here, and so we'll try to push that along a little bit more in the future. But one thing, I'm heading to the cross-CSC meeting tomorrow and Thursday, and so I guess I'd ask maybe Betsy and Susan from the management projects and Shannon and Dennis from the foundational science areas, if you could summarize in a sentence or two what you think the revamp concept means. I've been sort of indicated from the national office that no one knows what the revamp concept is except me. And I kind of think that, well, maybe I haven't done a good job articulating it, but I'm kind of curious what those 4 people would say, and then maybe that would take us to 10 minutes.
Why don't you call on us and see which ones of us want to respond? Right.
So let maybe Betsy, and then Susan, and then maybe Shannon and Dennis.
Okay.
Or I'm putting people on the spot, but just kind of like the revamp that we're building here at the Climate Science Center. If they kind of get and if you're like not sure what it means, that's a perfectly fine answer.
I mean, I could kick it off. I mean, I thought about it a lot, but to me, it means sort of looking at, sort of from the end-to-end management issues and bringing in, understanding the consequences that various climate changes are taking place and how those impact different natural resource or ecosystem components that managers are challenged with. And so by using the revamped framework, it provides us an end-to-end way of working from the management issues up through the natural resources to understand what aspects of climate change would impact the management decisions.
Cool, thanks. Anybody else have any, or in fact, anybody on the phone, or if
Hi, Jeff. This is Susan. I think in part because I'm here at the fort and have been familiar with the sort of the resources for advanced modeling, that looms large in my mind about a sort of a central function of revamp, and that is bringing together common analysis approaches and common databases to really facilitate this process in running impacts models, where we're combining, the best of the climate data and the land use data and ecological data. So I think about the resources for advanced modeling as being a very important component of the whole series of tasks within revamp.
Cool, thanks.
And this is Betsy Neely. My view of it is that what we're trying to do, or what the revamp is about, is providing tools and approaches to help us better understand the impacts of climate on nature and people, and then to help us better develop, more informed and robust adaptation strategies with decision makers. And so I see it as a bringing together of all these different disciplines to provide more robust adaptation strategies and implementation.
This is all great, and it sounds like, kind of maybe we are pretty close to be on the same page. I don't know if Shannon, as with your adaptation work, if you have any, I'm pretty sure you know what we're thinking about revamp, sitting so close to the center, but your comments would be valuable.
Yeah, so I think it's the philosophy that we as a center are a resource. In other words, we provide capacity to our partners to bring the relevant social, ecological, and climate sciences together to address natural resource management decisions. That was a sentence. That was pretty good. Yeah,
good. I'm glad we're recording all that. So, I'm glad we captured all that. So in the interest of time, I don't know if there's anything crucial or something anybody wants to ask anybody on the phone to know. We do have the social network analysis presentation in a few minutes that we need to sign off to get onto. So let me just pause and see if there's anything people want people to be aware of.
Jeff, I'll just say, in lieu of giving any rundown on the adaptation science activities, that we are going to be sending out our first, what's meant to be a quarterly NCCSC network newsletter this Friday. I believe we're going to send it out, and the focus for this first one is going to be on adaptation. So everything I was going to say anyway will be covered in there. So keep an eye out for that.
Thanks for one, recognize Shannon for spearheading that with Tyler, working here with her, and it's great to call that to people's attention and taking the initiative and having the adaptation be a first part of it. I'm looking forward to that newsletter, getting the word out a little bit about some of the stuff we're doing.
Yeah, and can I just add to that, Jeff, before we log off, that the next monthly check-in is November 18th, and Kevin Dobbs will be presenting on AmericaView, deployment of phenocams and research plans. So just to make sure that's on everybody's calendar.
Sounds good. And Stacey, thanks for starting the meeting and organizing it and watching that schedule. Maybe we can sign off, and we'll talk to everyone in not a month, because it's a week earlier next week.
Yes, it is.
Because of this. So it's not the 4th Tuesday, it's the 3rd, because we wanted to avoid the Thanksgiving week. But Stacey will send out
remarks. Same thing in December. December is the 16th to avoid Christmas. So we're avoiding Thanksgiving and Christmas by moving those 2 months a week early.
Great. Okay, thanks a lot, folks. We appreciate everybody joining in.
Yeah, thank you.
Thanks, everyone. Thanks, Andrea.
Thanks, everyone.
Hey,
Thanks, Andrea.